My name is Zach Kova with Minarik Drives, and in this video we're going to show you how to wire up and calibrate the RG500UA-PCM. Be sure to have your multimeter handy as we'll be using it during the calibration. The first step is to set the input and output voltage switches. The input switches are located next to the transformer and are factory default set for 230 volts AC. We're going to be using 115. There's also an input switch located on the PCM card, which is factory default set for 230 as well. So we'll move that to the 115 position. Next, we're going to look at the output and feedback switch. The first switch is for feedback. It's factory default set for armature feedback. If you're using tach feedback, you'd have to switch it to the tach feedback position. The switch behind that is the output voltage switch. It's factory default set for 180 volts DC. We're using a 90 volt motor, so we'll switch it to the 90 volt position. Next, we're going to connect the armature leads from the motor to the drive. These will go in A1 and A2. Now we'll be connecting our input signal leads to the isolation card. We'll be using a power supply to simulate our voltage input signal, and we'll be using a 0 to 10 volt range. Because we're using a 0 to 10 volt range, we'll connect our common lead of our source to the common terminal, or pin 7, of the isolation card, and the positive lead of our input signal to input 1, or pin 8, of the isolation card. Now we will connect our power leads to L1 and L2. We'll take the hot lead, connect it to L1, and then neutral to L2. L2 has two spots, one for 230 volts AC and one for 115. For this demonstration, we'll be using 115 volts AC. Next, we'll look at the dip switches located in the middle of the isolation card. The factory default setting is for the dip switches to be in the off position. This sets the isolation card to accept an input voltage signal. If you're using an input current signal, please refer to your manual for the correct positioning of the dip switches. Now that we've finished wiring up the drive, we have to calibrate the isolation card. The first step is to take the min speed trim pot on the drive and turn it full counterclockwise. And take the max speed trim pot and turn it full clockwise. We'll now apply power to the drive. We're now going to turn on our voltage source and apply the minimum input voltage signal we'll be using for our application. We're going to read across A1 and A2 with our multimeter and confirm we're getting 0 volts out. If we wanted a higher minimum voltage, we would just adjust the minimum out trim pot located on the isolation card. But for this demonstration, we'll be using 0 volts, like so. The next step will require you to calculate VTP, or the voltage test point. Please refer to your manual for the isolation card to calculate your VTP. For this demonstration, we'll be using a VTP of 5 volts. Now that we've finished calculating our VTP, we're going to apply our maximum input voltage signal to the isolation card. For our demonstration, that will be 10 volts. We'll now read across terminals common and TP. We'll use the input signal adjust trim pot to adjust the voltage across common and TP until we reach our VTP that we have calculated previously. We were using 5 volts as our VTP, so we'll adjust the trim pot until we read 5 volts on the multimeter. The last step to calibrating the isolation card is to read across A1 and A2 while applying the max input signal. We'll now adjust the max out trim pot until we reach 90 volts on the multimeter, which is what this motor is rated for. We'll turn the trim pot counterclockwise until we reach 90 volts. Now that we've finished calibrating the isolation card, we're going to go over a quick test procedure to confirm that we're getting the correct speed out of the motor we require for our application. So we'll cover the full input voltage range starting at 0 volts. We'll slowly increase our input voltage range to 10 volts. And then we'll reduce it back down to 0. And everything seems to be working properly. Thank you for watching this wiring demonstration brought to you by Minarik Drives. If you have any other questions, please feel free to visit us at www.minarikdrives.com or call one of our application engineers at 815-624-6950.